Hello, calculus student. This is chapter 4.1, related rates. The notes for this is in chapter 4, blank notes in Canvas, so you can download it and follow along. What is rates? Related rates is for tackling work problems that relate to functions. Well, relate functions of two variables, y and x. And then if we know the rate of change of one of them, for example, if I know how x changes over time and I specify it as dx dt, I can use the original function to relay it to dy dt. That means how y will change over time. And this can be vice versa. That means if I know how y changes over time, I can use the related rate equation to find out how change over time. Now notice in the original function, time or t is not involved. Your original function just relay x being the input and y the output. But if we know how x changes over time, we can use the original function to find out how y changes over time or vice versa. So these are all work problems. And particularly, we use chain rule to relate the two rays. So that's why the problems are called related rays problems. So to solve this problem, typically we have 5 steps. The first is after you read the question, involve drawing a figures or pictures of what's happening and assign symbols or variables to all measurements that changes. This is very important. A lot of students that weren't able to do related rate was they assign values to variables. If it is a variable that changes, then you should use symbols for it. Second is to determine in the question what rays is given and what ray is to be found. So do I need to find dy dt or do I need to find dx dt or what? Number 3 is find an equation that relates to two variables. So if you want to find dy dt, but you know dx dt because they give it to you, then you know that you need to relate x and y. You need to find an equation from the picture to see how the two variables are related. Step 4, use chain rule to relate the rates of the two variables. That means do dt over the two of the equation. We'll illustrate that in an example. And then step 5 is substitute the known value and solve for the rates to be found. Okay, so let's do example 1, which is a really basic one that does not involve any work problem. It's just a formula of x and y. It is given that y is 2x squared plus 1, so y is the function of x. And then somehow we know y is changing. dy dt is 5. That means y is changing over time at a rate of 5 per whatever time period that you want to specify. And then in this particular question, we want to find dy dt, or dx dt. We want to find out what would x change over the same time period when x is 6. Okay, so this is a little strange for a lot of people. They would say, well, if x is 6, I can plug it in and find y, and then how do I find how do I find dx dt's? So what happened is you would start off with this and notice that this is changing over time, this is changing over time. When x has a special value, you need a dx dt and dy dt equation. So let's look at the steps. So we don't have a picture for this. All we need to know is what is given. So this is given, dy dt is given, but this is what you need. And you notice that they're both for x and y, and we have the equation already. So the equation that relay x and y. So step 3 is already done. Step 2 is we know what is given and what is needed. And from here we know that we need to relay x and y, and which we did. So the next steps in this very simple question was to use chain rule to relay the rays of x and y from this. So since y equal to 2x squared plus 1, and we know dt is what we want, so we'll do dt on both sides. dt of y equal to 2x squared plus 1. So this is kind of like an operation, the operation that goes into each particular term. So we would have dy dt on this side, the left-hand side. On the other side, we'll have d dt of 2x squared. We also have d dt of 1. d dt of 1 is a constant. This is 0. d dt of 2x squared does not make sense because we can only do the derivative of x. The variable here is x. So we use chain rule. So we change it to dx because that's what we have. And remember the limit notation, we would change this to dx dt as if we are doing a fraction to, be able to cancel it, plus 0. And this, the other side is good. dy dt is just what we want. And so this would be just like a chain rule. It would be dy dt after you do this. The left-hand side is dy dt. And then right-hand side would be 4x, because when you do dx dt of 2x, d of dx of 2x squared is 4x, and then times dx dt, remember. So this is the rate of y, and this is the rate of change of x related to time, and that's how they related. So you have a related rate equation from the original equation. Now 5 is to substitute all the known variables, so you know dy dt is 5. And you know for x, x is 6, so 4 times 6. And dx dt is what you need. And I have everything known except this one. So dx dt would be equal to 4 times 6, 24. So divide 24, so 5 over 24 would equal to dx dt. Right, so this is the basic one. So basically you would, depends on how x and y related, to create a dy dt and dx dt equation. After you do that, then you plug in all the known one. If you know dy dt, you can solve for dx dt. If you know dx dt, you can solve for dy dt. And that's our answer of dx dt. dx dt is 5 over 24 per whatever units time that they have. Second example is the really basic question where it is very easy to find the relation between the unknowns. So it has usually it's geometry equations that we would use, like area of square, area of circle, area of volume of cubes, volumes of sphere or cylinder and stuff. So in this second example, we have area of a square and sides are related by a equal to s squared. So this is area and this is the size of a square. So we say s and s. If the side length s is changing at a rate of 6, so notice they didn't tell you what they're talking about, what variable they're given. So they say side length changing at a rate. So that means this means that ds dt is 6 per second. So time, you know that it's time because it's per second. What is the rate of change of area? Rate of change of area. So that means I need dA dt when side length is 5. S is equal to 5. So that's all we have. ds dt is 6, S is 5. What is dA dt? So obviously we notice that we need an equation that relate A and S, which we have already. So A is equal to S squared, but they do not relate. T doesn't show up here. So we'll do d dt on both sides of A and d dt of S squared. So this would become dA dt right away. We don't have to do anything, or actually even if you change it, it's just 1. And then we would change it to dds and then S squared. And then this would be ds dt attached to the back, just like when you do the implicit thing. So dA dt would equal to, we will be taking the rate of change of area to 2 times S ds dt. So this is the related rate equation. So now is the time to plug in. What is the rate of it? So this is the left-hand side is what we don't know, ds dt. And then we know 2 psi is 5 and ds dt is 6. So 2 times 5, 10, so it's 60. So when side length is 5 inches, the area is changing at 60. What is the unit? 60 inches square per what? This is a ray. And what is the time? Per second. So that's how you do this geometry one. So this third geometry one is this one. Radius of a sphere decrease at a rate of 2 meter per second. Radius, so r. Okay, so we draw a sphere, draw a picture, has a radius, but it is changing, so we call it r. It's not fixed. Find the ray, and then find the ray at which volume. Volume is v. Do we know the equation that relate them? Volume is 4 over 3 pi r cubed. So this is a geometry equation that relate volume and ray, because volume will be changing if r is changing, right? When r is 8, so that is later. So r is 8, do not write here because it's changing. It's just at the moment when r is equal to 8, what is the ray? So what do they want? The radius is changing at a ray, right? So that means dr dt is given. Dr dt is 2. And we need what? dv dt is unknown. And also we know r is 8. When we have the equation, we'll use this. When we don't have, we would just have this. This is static, right? Or this is in general when it is when it is changing. So we would need to do a dv dt versus dr dt. Related dv dt with dr dt. So do dt on both sides. Do dt of v, and then do dt of 4 over 3 pi r cubed. So 4 over 3 pi are just constant, so we can move it out. And then we, our variable is r, but we have t, so we can do a derivative here. So we change it to dr, 4 over 3 pi, so this doesn't change, r cubed, because this is changing, this is also changing, we do a derivative of it. But then we have to multiply dr dt at the back. So dv dt is good on this side because we only have v. So what would this become? 4 over 3 pi is just a constant multiple. So we say 4 over 3 pi times 3r squared. They're usually easy things to do, easy derivative. And then dr dt. So this is the related rate equation. The original equation is this one. This is the related rate equation. Now we're ready to find dv dt because that's what is the unknown. And it just happens that we just plug it in. Okay, so dv dt would equal to what? 4 over 3. Oh, we can just cancel this. 4 pi r squared, 4 pi r squared dr dt. We have everything. We have 4 pi, so that means 4 pi. And we have r is what? R is 8x squared. And what is dr dt? Dr dt is 2. So we have 64 times 8, 512, I believe, right? So be 8, 512 pi. And what is the unit? It is a ray, so it be per second. What per second? Volume. Volume will be meter cube per second. So for the exact value is 512 pi meter cube per second. For approximate value, you can multiply pi. It will be 1608.5. 0.5 meter cube per second.